Alright, in this video I'm going to do an example of using Cramer's rule to solve a 3x3 system of linear equations. So here we've got x plus 2z equals 9, 2y plus z equals 8, and 4x minus 3y equals negative 2. The first thing I'm going to do is make my coefficient matrix. So we've got a 1x, we have 0y, and we have 2z. And then our second row we have 0x, 2y, and 1z. And then we have 4x, negative 3y, and 0 z's. Okay, so the first thing I'm going to do is figure out the determinant of this matrix. This will be our d value. So again, there's different ways you can find the determinant of a 3x3 matrix. I like to just do the expanding along a row and then calculate corresponding 2x2 determinants. So let's see, we'll have 1. If we were to cover up that row and that column, it looks like we would have 2, 1, negative 3, and 0. Then we use a negative, the next entry, which is 0. Again, it doesn't really matter what we get here, we'll just get 0, but let's write it down anyway. We would have 0, 1, 4, and 0. And then plus 2 times, okay, so if we cover up the last row and column, it looks like we'll have 0, 2, and 4, and negative 3. So if we compute this, we'll get 1 times, it looks like, well, 2 times 0 would be 0, minus negative 3 times 1, that would give us positive 3. Our next entry is going to turn out to be 0 since we're multiplying by 0. Then we'll have 2 times, again, it looks like 0 times negative 3, which is 0, minus 4 times 2, which would be 8. Alright, so it looks like, in this case, we're going to get 3, looks like minus 16. So if we do 3 minus 16, I'm getting negative 13 for our value for d. Okay, and now this is where we have to go back and compute our other determinants as well. So to figure out our d sub x, we're going to look at the matrix. So remember, when we do our d sub x, we leave the x column, well, the x column is the one that will change. We leave the other columns alone. So I'm going to leave the y column alone, and I'm going to leave the z column alone. And recall, we just take our values that were on the other side of the equal sign. So 9, 8, and negative 2. And those are the values that I fill into the matrix. So let's see, the same thing, I'm going to do my little determinant, to calculate the determinant, I'm going to expand along the row. So I'm going to just expand along the first row, same thing as before. So we'll get 9 times, it looks like 2 and 1 and negative 3 and 0. Then we'll get minus 0 times, well, who cares? Again, we're just going to get 0 out at the end of it anyway. And then we'll get plus 2 times, let's see, so if I cover up the last column and the first row, it looks like we'll have 8, 2, negative 2, and negative 3 left over. So 8 and 2 and negative 2 and negative 3. So let's see if we can't do the arithmetic here. So we'll have 2 times 0, which is 0, minus negative 3 times 1, which will give us a positive 3. Our middle term is going to be 0. And then we'll have plus 2 times, let's see, it looks like 8 times negative 3, which is going to be negative 24, minus, let's see, negative 2 times 2 would be negative 4, so we'll actually get plus 4. Well, let's see, 9 times 3 is 27. Negative 24 plus 4 would be negative 20. So it looks like we have 27 minus 40, and 27 minus 40 is going to give us a value of negative 13. Okay, so there's our d sub x value. So let's see, so we figured out d back here was negative 13. I'm going to keep them all over here to keep it organized. We now figured out our d sub x value was also negative 13. Alright, so next we have to compute our little d sub y value. So to do our d sub y, okay, again, Now I'm going to leave the x column, the original x column alone, so 1, 0, 4. I'm going to leave the z column alone as well. And then again, just like before, now I replace the y column with these values 9, 8, and -2. So I'm going to compute my determinant. You could expand along a different row because there's some zeros, but I don't know, I'm just going to still expand along the first row. So we'll get 1 times, let's see, we would get this 8, 1, -2, and 0, plus, so the middle sign, so we start off with a positive, so we have 8, 1, -2, and 0. The middle sign needs to turn into a negative. We flip the sign, so we'll have -9. And if we cover up that row and that column, it looks like we have 0, 1, 4, and 0 left. So you can see there's just tons of arithmetic in these. It's certainly easy to make a mistake. Our last entry, we have a +2. We leave that sign positive. If it looks like we would get 0 and 8, and then 4 and -2. So now if we compute this, this will be our d sub y. Looks like we'll get 8 times 0, which is 0, minus -2, or we'll get a +2, minus 9 times, well, 0 times 0 is 0. We'll get minus 4 times 1, or -4. And then it looks like we have 2 times, well, 0 times -2 is 0, minus 4 times 8, which would be 32. Okay, so if we do the arithmetic here, 1 times 2 is 2, -9 and -4 is positive 36. It looks like we have +2 and -32, which would be -64. Okay, so let's see, what is that? So we've got 38 minus 64. If we take 38 minus 64, it looks like to me we're going to get -26 for our d sub y. So let's see here. We now have our d sub y to equal -26. So one last one here. We've got to calculate our d sub z value. So to get our d sub z, we're going to look at the matrix. So we'll leave the x column alone, we'll leave the y column alone, and then we're going to, in our z column, we'll use these new values of 9, 8, and -2. And again, we just got to compute the determinant of this new matrix, coefficient matrix. So we'll have, so if we expand along the first row, we'll have 1 times, it looks like 2 and 8, -3 and -2. We've got to change the sign on the middle, but again, we're multiplying by 0, so I don't even bother to figure it out because I know it's all going to turn into 0 anyway. Plus 9, and then if we cover up the last row and the last column, it looks like we've got 0, 2, 4, and -3 left. So now we have to compute this last value, so we're having fun here. So 2 times -2 is -4, minus, let's see, -3 times 8 would be -24, so we'll get a plus 24. Our middle term is going to be 0. And then we'll have 9 times, okay, whoops. So 0 times 3 would be 0, minus 4 times 2, which would be 8. So let's see here. It looks like we have -4 plus 24, which would be 20. Plus, let's see, 9 times -8 would be -72. -72 plus 20 is going to be -40. Oh man, how about -52? So now we've got our d sub z value. So it says d sub z is going to have the value -52. And now all we have to do to actually calculate our solutions, again, is it says to get our final solutions, we take our d sub x over d, y is going to be the d sub y over d, and then our z is going to be our d sub z over d. Well, our d sub x, we got -13 over -13. That's going to give me an x value of +1. d sub y is negative 26, again over negative 13. So negative 26 over negative 13 is positive 2. Our d sub z value was negative 52. So negative 52 over negative 13 is positive 4. So it says our solution to our original system of equations is 1, 2, and 4. So as you can see, again, pretty long problems. You saw me almost make a couple little mistakes there. So you really have to be a good bookkeeper on these problems. You know, if you miss one little computation, one little sign, any one little arithmetical mistake, by the time you get to the end of it, obviously, you know, you're going to be off by a good bit. So the moral of the story on these, if you have to do them especially by hand, take your time, be careful, get it right the first time.